This video goes with the math connection over molarity. This is part 1, concentration of reactants in solution, or molarity. Molarity is a ratio of the number of moles. Okay, remember we showed number of moles with a lowercase n. I know that doesn't make a lot of sense, but that's just what they chose, mostly because there were too many m's already in play. So lowercase n is number of moles of a substance or solute dissolved in a volume, capital V for volume, in liters of a solution. Okay, that in liters will be a tricky part because a lot of the questions coming up are going to give it to us in milliliters instead. All right, so I know you don't have access to your green periodic table, but if you did, I would direct you to the back of it where it talks about solutions. We're going to use 2 of these formulas today. The first one is over molarity, which you read about in the other assignment. Molarity equals the moles of solute per liter of solution. So it's showing how concentrated it is. So if you add more water, it's going to have a lower molarity. Less water, higher molarity, or a stronger concentration. So we can use this in a triangle formula. The molarity equals the number of moles divided by liters. The liters equals the number of moles divided by molarity. And the number of moles equals molarity times liters. Okay, and then the other one is going to be the second half of the worksheet. We'll have V1M1 equals V2M2. This is for diluting a solution. If you have volume 1, and on our worksheet it's going to show volume I instead of volume 1. It still means the same thing. That's just instead of using 1 and 2, the worksheet uses initial and final. So we have volume 1 times molarity 1 equals volume 2 times molarity 2. So whenever that you see it on the worksheet in a minute, it'll say VI, volume initial, molarity initial, equals volume final. It'll be VF instead of V2. VF, volume final, molarity final. All right. So just to kind of review, here's our first formula that we're going to use. Molarity equals the number of moles times the volume. Just to go ahead and have that equation ready to go. If we were solving for N instead, the number of moles equals molarity times liters. And if we needed the liters, that would equal the number of moles over molarity. So there's the 3 ways that we will see this equation. Use this information in a periodic table to answer the questions below. Okay, again, I understand we left school without a real plan. We didn't know we weren't coming back when we left after spring break, so I don't expect you to have the periodic table. All of the molar masses will already be calculated for you. At this point, you've either learned how to do molar mass and you're really good at it, or you're not going to learn that part, and that's okay too. Don't worry about it. The molar mass will already be done. Number 1. Sulfuric acid is a highly corrosive acid used as an industrial cleaning agent to remove rust from sheet metal. What is the molarity of a solution made by dissolving 6.652 grams of sulfuric acid, H2SO4, in water and diluting to a final temperature of 70 ml? Step 1. All right, notice I said that volume will be in liters, and that's going to be tricky because we're often given we have equipment in the lab that works in milliliters. So we're given this in the problem as 70 milliliters, which is realistic because that's what we would run into on our equipment if we were measuring this out. So the first thing we need to do is to convert milliliters to liters. Okay, and to do that, you could put in the calculator 70 divided by 1,000, or you could simply move the decimal back 3 places. 1, 2, 3. So this will be 0.07. And whether you put those zeros after that or not, technically we should put them because it's significant digits showing that it's measured very precisely. But if you just put 0.07, you're still going to get the same answer in the end. Okay, step 2. Use stoichiometry to calculate the moles of H2SO4 in 6.652 grams. So this is just simply converting moles to grams. So we take the number, unit, and substance. Number's a little harder because there's 2 different numbers in the problems. We want the number of grams to convert it to moles. We already converted milliliters to liters. We want to convert grams to moles. So we have 6.652, that's our number, and then the unit and substance that goes with it. 6.652 grams of sulfuric acid. Okay, we bring our unit and substance down and over. Now you'll notice we drew a wall rather than parentheses. So this was just a wall is what we were used to seeing right here. And we left this one blank. Just ignore that. Okay, so our unit and substance, grams H2SO4, grams of H2SO4 gets moved over, and we change from grams to moles of the same substance. Okay, that what allows us to do this is the molar mass. So this number that just appeared out of the blue that's not anywhere in the question, this is the molar mass of H2SO4. All right, so we have 6.652 times 1 divided by 98.0785. All right, so we've talked about some issues with your home calculator, the calculator on your phone. Just a simple calculator like you might use to add up to, pay bills or make deposits or whatever. So all calculators are not created equal here. So we'll enter this in carefully and just one thing at a time instead of how we normally would just put it all in at once in class. All right, so we've got 6.652 times 1. I'm not going to put times 1 in the calculator. Then I get to the big long line. The big long line says divided by, so I hit divided by 98.0785. You can see they calculate their molar mass a lot more precisely than I usually do. I usually just round it to the nearest whole number, but since they've done the work for us, let's just go with it. All right, so this equals 0.0678. All right, so now we have the number of moles. All right, so use the formula for molarity to calculate the molarity of the solution. Molarity equals the number of moles divided by the volume. Molarity equals the number of moles divided by the volume. Okay, we've calculated the number of moles, 0.0678. We've calculated the volume, 0.07. Doesn't matter if those zeros are on the end or not. Equals. Okay, I've already got the first number in my calculator, so I'm just going to hit divided by 0.07 equals 0.9, and then that 6 is going to round up to the 7 because 8 is 5 and up, so bump it up. And this is big M for molar. Okay, not too bad, right? Let's do another one together. Number 2. Nitric acid, HNO3, is used as a reagent in liquid-fueled rockets. The molarity of nitric acid is 16 molar. How many moles of HNO3 are in 450 milliliters of 16 molar solution? All right, so the question is, how many moles? We've got our volume, and we've got our molarity. So the first thing we want to do is to convert our volume into liters. So again, just bring your decimal back 3 times. You could also put this in the calculator, 450 divided by 1,000, and it would give you this same thing. It's not a very good 5. Let me fix it. All right. So that is just converting milliliters to liters, so we have a volume. Okay, and then we've already got molar. So that looks good. All right, so this time I'm wanting to know how many moles. So I want to know how many moles. So N equals molarity times liters. Number of moles equals molarity times liters. Okay, the molarity is 16 times the liters, 0.450. I put this into my calculator. 16 times 0.450, 7.2 moles HNO3. Not too bad, right? Just 3 variables, figuring out which one's volume, whether it's milliliters or liters. If it's milliliters, convert it to liters. The one with the capital M following it, that's the molarity. And then if you have moles, that's your lowercase n, number of moles. All right, number 3. How many moles of solute are present in the following solutions? Okay, let's look at them one at a time. Let's just look at A. 2.85 liters of 1.59 molar LiNO3. Okay, I guess it's wanting you to solve for N. I've already arranged the formula for you over here. N equals M times L. N equals M times L. All right, so the number of moles equals the molarity, 1.59, times the liters, 2.85. Put that in the calculator. 1.59 times 2.85 equals 4.53. And this is moles. Okay. B, 2.39 milliliters of 0.156 molar hydrochloric acid. Okay, you can set it up the way that they have here and solve for N if you're really good at algebra. If you're not really good at algebra, then remember we have N equals ML, which equals, and that's just the formula that I gave you at the beginning, right? Nope, wrong one. This is the formula I gave at the beginning, right? This is the formula we were given. These are the different ways to arrange it to solve for N or solve for L. So this is N equals ML. So I didn't just make it up or didn't just know to multiply them. I looked it up right here where I have it all arranged, easy to solve. All right, so molarity, 0.156 times, and then I need to bring this back 3 places, 1, 2, 3, so 0.0239 equals, clear on my calculator, and this is 0.156 times 0.0239 equals 0.00373. 0.00373, and this is solving for N. N is number of moles, so this will be moles. Okay. Number 4. How many grams of solute would you use to prepare the following solutions? Okay, so problem A, 1 liter of 0.25 molar sucrose. All right, so we want to know, the question asks, how many grams? So we're going to solve for moles and then convert moles to grams. Okay, this would be a good time to pause the video and see if you can work through this on your own. And then after you've worked through it on your own, come back and hit play and make sure you did it correctly. All right, step 1. Use the molarity formula to calculate the moles of sucrose. So we have number of moles equals molarity times the liters. Okay, that's still from this beginning formula. Number of moles equals molarity times liters. So, number of moles equals molarity 0.250 times 1, which of course we don't need a calculator for, equals 0.250 moles. All right, so now it wants to know, you'll use stoichiometry to calculate the grams of H2SO4 you need to prepare the solution. The molar mass of sucrose, like I said, molar mass is all done for us, is 342.2965 grams per mole. All right, so 0.250 moles of this. Now, we're not used to seeing it as times. We're used to drawing a wall and bringing our unit and substance down and over. So we have number, unit, and substance. And for us, we usually leave this blank, so just ignore that one there. You bring your unit and substance down and over, and you convert from moles to grams of the same substance using molar mass. So we have 0.25, and then this wall says times 342.2965 equals 85 point, and we'll round this 5 to a 6 because 7 is 5 and up, so bump it up. 85.6 grams. See our unit and substance here transfers past the equal sign. 85.6 grams of C12H22O11. And that is our final answer. Okay, B. 0.0673 liters of 28.86 molar hydrogen fluoride. Step 1. All right, let's go back. Our question is kind of up here. It's asking how many grams. So we're doing the same thing as we did before. We're figuring out the number of grams. So first we calculate the number of moles, and then we use stoichiometry to convert grams to moles. All right, so again, number of moles equals the molarity times the volume. Molarity times liters. The molarity is 28.86 times the number of liters. It's already in liters, so we don't have to convert that. 0.0673. And this is going to be a little messy. I'm going to jump across this. Sorry. All right, so we're going to put this in the calculator. We have 28.86 times 0.0673 equals 1.94, and this is moles of HF. There's a typo here. This shouldn't say sucrose, this should say HF. All right, so there's our number of moles. Okay, and then step 2, use stoichiometry to calculate the grams of HF you need to prepare the solution. The molar mass of HF is 20.006343 grams per mole. All right, so our number of moles of HF, 1.94 moles of HF. And then we're not used to seeing it as times and fractions. We're used to having a long line here and a wall built here. You move your unit and substance down and over, change moles to grams using molar mass, always goes with grams. All right, so we've already got this number in our calculator, times 20.00633 equals 38 point, and then that 8 is, that's 5 and up, so I'm going to bump that up to a 9. So this will be 38.9 grams of HF. All right, number 5. How many milliliters of a 3.5 molar iron 2 nitrate solution are needed to provide a total of 130 grams of iron 2 nitrate? Step 1. Use stoichiometry to calculate the moles of iron 2 nitrate needed to prepare the solution. The molar mass is 147.8560 grams per mole. All right, so we're going to convert. It's giving us, it says how many milliliters. So it wants to know the volume, how many milliliters, and it's going to give us in liters, so we'll have to convert to milliliters at the end. And it wants us to, in 3.5 molar and 130 grams. So the first thing we need to do is convert grams to moles. Then when we have moles, we can convert, or we can use our beginning formula to see, for volume, liters equals number of moles over molarity. And then we convert from liters to milliliters. Okay, this would be a good place to pause the video and work this problem on your own. And then after you're done, come back and check, or if you get stuck, then hit play and see how to do the rest of the problem. Okay, hopefully you did well doing that one on your own and were able to figure it out. If you weren't able to figure it out, no worries. We've got it on the video coming up right now. All right, so we start with number, unit, and substance. We start off with the grams of iron 2 nitrate. So 130 grams of this substance. This is the iron 2 nitrate. Number, unit, and substance. You draw your first wall, and you bring your unit and substance, grams FeNO2, grams FeNO2, you bring that down and over. We leave this box blank. All right, you use molar mass to convert from grams to moles of the same substance. So this is 130 times 1, I'm not putting that in the calculator, divided by 147.8560 equals 0.879 moles. Okay, now that I have moles, step 2, use the molarity formula to calculate the volume in liters. All right, so we have liters equals the number of moles over molarity. Liters equals the number of moles over molarity. Okay, our number of moles, 0.879 over the molarity, that'll be in the question, 3.5 molar. Okay, that first number is already in the calculator, so I can just hit divided by 3.5 equals 0.251 liters. Okay, so this is 0.251 liters. We need to bring this decimal over 3 places to turn that into milliliters. So this is 251 milliliters of iron 2 nitrate. All right, one more problem using this formula, and then we'll switch to the dilution formula. Number 6. If a chemist has 2.4 grams of silver nitrate and needs to prepare 1.5 liters of 0.01 molar solution, will there be enough silver nitrate? If yes, how much is left over? If not, how much more is needed? Okay, this is a good place to pause and work through the rest of the problem, see if you can figure it out on your own. If you can, great. If you can't, no worries. Just go ahead and hit play and let it walk you through it. Okay, step 1, use the molarity formula to calculate the moles of silver nitrate. All right, so we're going to go ahead and make the algebra easier. We're going to arrange this formula like we were given at the very beginning. N equals M times L. Okay, the molarity is right here, 0.010. The liters is right here, 1.5 liters. We put that in the calculator, 0.01 times 1.5 equals 0.015. And this is moles of AgNO3. All right, so we have 0.015 moles of AgNO3. There's our number, unit, and substance. Bring down your unit and substance. So this is what we're used to seeing, is it more like this. Okay, and then here's our molar mass. So we already have this number in the calculator. This wall says times, so times 169.8731 equals. Okay, we're going to do 2.5, and then this 8 is 5 and up, so it bumps that 4 up to a 5. So this is 2.55 grams. Compare the amount of AgNO3 needed for the solution to the amount the chemist has. Does the chemist have enough? So it looks like the chemist has 2.4 grams. They need 2.55 grams. So no, that is not going to be enough. Think about how we're going to get how much more they need. What are you going to do with those two numbers? Pause for a moment if you need time to think. The chemist needs 2.55 grams. The chemist has 2.4 grams. So if you take what the chemist has minus what the chemist needs, that'll give you 148 more grams are needed. Okay, so that's the difference between those numbers. They have this much, they need this much. So to have what they need this many more grams. Okay, that concludes questions 1 through 6 on math connections. We'll do a separate video because this one's too long to have just one. We'll do a separate video for the dilution. The dilution ones are easier.